Okay, today we'll be solving systems of linear equations by substitution. So we will be learning two different ways to solve these algebraically. The first one's substitution, and today we'll just be working with a single term substituting. So I'm going to first go through one example before I go through the steps. So I have two equations, and I need to find the solution. So remember, when we were solving systems of equations by graphing, we would graph both of the lines on the same graph and find where those lines intersect, and that was the solution. We are going to learn how to solve it algebraically without a graph. So we're still finding a point where the two lines intersect. We are just finding it algebraically instead of looking at a graph. So the first thing I'm going to do is figure out which term I want to substitute in for the other one. So if I have y equals 4x, I can substitute that in for the y in the other equation. So if y equals 4x, then I'm going to make y in this equation equal 4x. So let me write that out so that it makes sense to you. 4x equals negative 2x plus 30. So that is now what I have to solve. Now that I have only one variable, x, in the equation, I can figure out what x is. So remember, when we're solving, we want to get the variable over to one side. So I'm going to add, 2x to cancel it out on the right side. Add 2x. Now I have 6x equals 30. Last step is to divide by 6. And now x equals 5. So I know that x equals 5. Now that I know that, I can figure out what y is, because I know that y equals 4x. If y equals 4x, then I could say that y equals 4 times 5. So y equals 20. So the solution is 5, 20. That is the point where these two lines would intersect on a graph. So now that you've seen one example, let's go through the steps that I followed. So step 1 would be to identify one equation that isolates one variable, x or y. So you're trying to find one of the equations that has one of the variables, either x or y, by itself on one side of the equal sign. You may need to rearrange the equation to solve for one of the variables. So if both equations have x and y on the same side of the equal sign, you might need to rearrange them. I don't think we'll be looking at any of those examples today, though. Step 2 would be to substitute for that variable into the other equation. So that's when we took 4x and put it in for y in the other equation. Then you're going to solve the equation from step 2. Step 4 would be to substitute again. The result from step 3, so that's when we found what x equals, we substituted it back into the equation from step 1 to find the value of the other variable. Step 5 is to write the answer from steps 3 and 4 as an ordered pair, x, y. Then you can check. So we didn't do that yet. Let's check to make sure that this solution is correct. So I'm going to, over here in the margin, check my answer for number 1. So what that means is I take this solution, 520, and I plug it into both of those equations to make sure that the end result is true. So let's start with the first equation, y equals negative 2x plus 30. If y is 20 and x is 5, I'm going to plug that in here. So 20 equals negative 2 times 5 plus 30. So I have 20 equals negative 10 plus 30, and 20 equals 20. So that one works. Let's try it in the other equation. My other equation was y equals 4x. So that would be 20 equals 4 times 5. So 20 equals 20. So that works too. So now I know I have found the correct solution. Let's go to number 2. Y equals negative 3x plus 24, and y equals 5x. So since I have a single term, I'm going to substitute in 5x for y in the other equation. So y equals 5x. That means I can take this 5x and put it here for y. So 5x equals negative 3x plus 24. And now I can solve this for x. Add 3x to cancel out. Add 3x. Now I have 8x equals 24. Divide by 8. X equals 3. And now I can plug it back into one of these two equations. I'll pick the smaller one, y equals 5x. So y equals 5 times 3, because 3 is x. So y equals 15. So my answer is 315. 3 is x and 15 is y. You can again check your answer if you wanted to. Take both of those equations, plug in 3 for x and 15 for y, and make sure they work out to equal what they say they equal. Number 3, negative 2x equals y, and 4x plus 10y equals 16. So in the first equation, I have y isolated on one side. So I'm going to substitute in negative 2x for this y here in the equation. All right, so, I have 4x plus 10, and I'm going to put negative 2x instead of y, equals 16. Now I can solve this. So let's get rid of the parentheses first. 4x plus, well, I'm not going to put a plus sign yet, 10 times negative 2x is negative 20x. Now I can combine these like terms. 4x and negative 20x, that would be negative 16x equals 16. Divide by negative 16, and x equals negative 1. Now I can plug in negative 1 for x to figure out what y is. So now I have negative 2 times negative 1 equals y. So negative 2 times negative 1 is 2, so y equals 2. My solution is negative 1, 2. Remember, x goes first, then y. Number 4, y equals x, and negative 2x minus 5y equals 35. So in my first equation, y equals x, both variables are isolated to one side. So really, you could pick either one. What this is telling you is that x and y are the same value. Y equals x. So just pick one. I'm going to substitute in y for x here. You could substitute in x for y. It's up to you as long as you put it in the right place. So I have -2, and instead of x, I'll put y minus 5y equals 35. So the goal, remember, is to get only one variable in your equation. So now I only have y's. I don't have any x's. Now I can combine like terms, -2y and -5y, which is -7y equals 35. Divide by -7, y equals -5. So now that I know that y is -5, I can substitute in -5 for y equals x. So remember, we knew that x and y were the same. So x is -5 and y is -5. So -5, -5 is the solution. Okay, now I want you to pause the video and solve numbers 5 and 6 on your own, and then come back and see if you got the right answer. So go ahead and pause now. Okay, so if you come back, hopefully you've already solved for 5 and 6. I'm going to give you the answers. So for number 5, the solution was -4, 2. And for number 6, the solution was -1, -3. Now, if you did not get those right, you might want to go back and watch these examples again. But this is what you'll be doing on today's practice, substituting to solve a system of equations algebraically.